So good evening. So I'm going to teach you about diodes as an introduction as well as the rectifier in this video, and in the next video I can go for more. Okay. So first you should know what is a diode. So diode means di represents two. So di means two, and then ode. Ode is actually the portion of electrode. From this electrode, actually, this alone being taken and dye is also taken. So combining these two, we have this naming as diode. Okay, so it has two terminals. Electrode means terminals. So what are the two terminals available here? It has two terminals. They are named as anode and cathode. Okay. So the anode is always positive and the cathode is negative. And in this diode, how we are representing it, this is this symbol. Okay. The symbol in the sense this is an arrow mark like or a triangle shape that represents your anode, and this vertical line that represents your cathode. Okay. So here this represents your anode and this line represents your cathode, and for taking the connection we are having this leads that are not important here. Actually these thing is representing your cathode. This is the symbol, this is representing your diode. This is the symbol for diode. Okay. So where is it? Okay, so this diode is actually made up of semiconducting material. So based upon the semiconducting material, we have actually two types. One is it can be made up of germanium or it can be made up of silicon. So you can have the germanium diode or you can have the silicon diode. Okay, and based on application, we can have so many number of diodes. Something like we can have the rectifier diode, we can have light emitting diode or Schottky diode. We can have the Zener diode, light emitting diode LED. Okay, then you can have the photodiode. You can have varactor diode. So based on the applications, you have the different diodes. Okay. So for the very simple basic type of diode is what? A basic type of diode is actually the Pn junction diode. It is made up of P-type material as well as the N-type material, and the meeting point is the junction. Okay. So this is the symbol for Pn junction diode. Very simple. This is the symbol. Right. And when you go for the other thing like Schottky, so this is one type. Then if we go for the Schottky diode, for that the symbol is this anode is as such, but here it comes like this. That represents your yes. It is something like this. So understand this. By seeing the cathode itself, you can identify. So you have the shape like this, isn't it? So that is the yes. That's why it is the Schottky type. Then the third one is Zener diode. So Zener means is Z. Z is there. So the anode is as such. For this Z symbol, it would be given like this. That's it. Okay, this is an diode. And you have the tunnel diode also. So tunnel, it should be in the shape of the tunnel. You know what is a tunnel. So for the tunnel shape, it is given like this. Okay, this is the shape of the tunnel diode. And for LED, the symbol is like this. So you have the anode and you have the cathode as like the PN junction diode, but it is emitting light rays. Okay, from the anode, light rays are being emitted. So it is the symbol for or schematic symbol for LED. Okay, then for photodiode, actually, photon or photo means what? Photo means light. Okay, so in this you have the diode like this, in which it conducts current when the light rays are falling on it. Okay, so this represents your photodiode. Then the next type we can take, that is the varactor diode. So that is your seventh type. So varactor. So here you should know what is varactor. Varactor means variable capacitor. You should understand that it is variable capacitor. So with the help of that we can tune. Okay, to any, it can be tuned to any frequency. Automatically it can be tuned. Okay, the capacitor can be tuned. So varactor represents actually variable capacitor. So the symbol is like this. This is your anode. Therefore the capacitor, you have the capacitor symbol, isn't it? So this is the capacitor symbol available. So it is the varactor diode. So now we go for the application wise. The first we are taking the rectifier. So we'll see that first. We have the rectifier diodes. So before going to see about this rectifier diodes, you should know what is meant by rectification. Rectification is the process. Okay, it is the process of converting AC to DC. AC signal to DC signal. Okay, so that is the simple definition we can give. Further, we can go into elaborate like this. What is the meaning of that AC? AC means alternating, isn't it? It is the alternating current. So it is an alternating signal. So how it would be looking like if you are taking a reference line, something like this. If you have the uh, plot like this, graph like this, then in this the current will be varying something like this. Continuously it is varying. Okay, so this is the alternating signal. In this alternating signal, you have the positive portion like this. This is the positive half cycle. We call it as the positive half cycle. And we have the negative half cycle. This is the negative half cycle. This portion is the negative half cycle. So both positive half cycle and the negative half cycle will be present in an alternating or the AC signal. It is a sinusoidal signal actually. Sine waveform. Okay, so it is a sinusoidal signal. So it has the both polarity, two polarity it has. What is bipolar signal? It is also called as bipolar signal. Two polarities in the sense positive as well as negative. Okay, so like this we can represent the AC signal. So we have to now go for what is a DC, right? So DC means actually here direct current. DC represents, what is the meaning of DC? DC is direct current. AC is alternating current. DC is direct current. So with the help of the graph, if we show, if this is your graph, right? This is x-axis and this is y-axis actually. But in the x-axis, we represents time actually usually. This is your time axis and this is your amplitude, right? So in this, it would be something like this, constant value. This is your constant value, that is the direct current. So for direct current, the amplitude will be a constant one. It is not at all varying like this. Okay, here it is varying. That's why it is a AC signal, but it is not varying. It is a constant one. Then it is a DC, and it is either it would be having positive value or it would be having negative value. So it has only single polarity or unipolarity. Okay, it won't be having two polarity signal. Only either it would be having positive or it would be having the negative value. But this direct current is so here constant, I have told you, right? So this current, direct current is actually called as a pure DC. But in the rectification process, what is happening? The rectification process actually, it is a process of, I have simply told you, it is a process of converting AC signal into DC signal. But the perfect definition, if we give the perfect definition, is rectification is the process in which AC signal will be converted into pulsating DC. That is the perfect definition. Okay, so what is rectification? It is the process of converting AC signal into pulsating DC signal. Like that we define it. So what is the meaning of this pulsating? Pulsating in the sense it can be represented like this. So you can have this amplitude along the y-axis and time along the x-axis. Then it would be varying. It can vary something like this, but above the reference axis or the time axis. So it is having only positive values, but it can also having the variations. Okay, so then it is called as a pulsating DC. So this is the definition of rectification. So our ordinary PN junction diode can be used as a rectifier. So to now we are going to see about the rectification process. Okay, so rectifier diode. So here how we will be having the circuit will be like this. You have the diode connected here, then the load resistance. So in this circuit only three components are there. This is your source, right? This is V input you are giving. This is alternating current, and this is your diode, and this is your, in this diode actually you have this anode side and this is your cathode side, right? And this is your load resistance. Only three components, and this source will be supplying. But how it is actually supplying? This is your input, right? Isn't it? This is your input, and you are going to measure the output across this load resistance. Here you will be measuring V out, output voltage. V in is input voltage. Understand that? V in is input voltage and V out is output voltage, right? So this Vin is a AC. You should know that it is a AC signal. So the how the AC signal will be appearing? AC signal will be like this. It consists of positive half cycle as well as the negative half cycle, and it is continuously varying, something like that. Okay. So here it has the amplitude and here it has the time. So we can take the time something like this. It varies from 0 to T1, and so in your reference book, it is in your material, it is given as T0 to T1, then T1 to T2, like that it is given. So during T0 to T1, you will be having the positive half cycle, isn't it? It has only the positive values. This portion continuous, this complete portion will be having the positive value. So when the positive value is appearing, it this becomes positive and this side will be negative. Okay, already we know that this is anode and cathode. Now anode is always positive, this cathode is always negative. So when this positive is being connected to positive, understand this, this is during positive half cycle. I am representing about during positive half cycle. Positive half cycle of input voltage or the input signal or Vn. Okay, so when the Vn is positive, like this. So this becomes plus, this becomes minus. We know already this is positive and this is negative always. So when this plus is connected to this plus, diode is getting forward bias. Understand that diode is called forward biased. So during forward bias condition, the diode acts as a short circuit. It acts like a short circuit. Understand? Okay. So short circuit means we can replace this by, I can replace this by a simple line. So this is the representation of short circuit. During the forward bias condition, a diode can be replaced by a short circuit. So then what would happen automatically? The current starts flowing in this direction. Current I will be flowing in this direction. Because of this current, all the voltage, input voltage will be appearing at the output side. So that is in the sense across the RL load resistance. Because of this current flow, output voltage will be available and this output voltage will be equal to V input. Understand? So how the waveform will be there? This is your input. This waveform is input. So if you take the output voltage, here now I am representing your output voltage. Okay. So this is your amplitude and this is your time axis from T0 to T1 and then T1 to T2. If you represent, you will be getting the exact input as the output. The same thing as the input. Okay, so the same input will be here available as the output. This is the representation actually. Right? Complete voltage will be here available for you. Right, fine. Then what would happen? Automatically, since it is varying from T1 to T2, now the negative half cycle is being applied at the input side. So now we have to draw, once again I need to draw this, how the circuit will be there. So this is your circuit as such. This is your resistance, load resistance. Okay. So this is your V input, but at V input, the negative half cycle is appearing, not the positive half cycle. The negative half cycle is coming here. So when the negative half cycle is coming during this period T1 to T2, this becomes minus and this becomes plus. Understand that? This becomes minus and this becomes plus. But you always, this is your positive side because this is your anode, this is your cathode, isn't it? So this is always plus, this is minus. So what is happening here? This minus is connected to plus. Minus is connected to plus means we say that this diode is reverse biased. Understand that? During, this is the second case. During the negative, so when Vin is equal to negative half cycle. Okay, in negative half cycle, this diode is getting reverse biased. So reverse bias means what? It acts like a open circuit. So open circuit means how it would be. So simply it is getting open, that's it. So this is cut off. Okay, it won't, it does not, though there is diode is present there, but there is no electrical connection. It is simply acting as a open circuit. So this, if this is a open circuit, there is no possibility of current flow through this circuit. Okay, since it is broken. Okay, it is an open circuit. So because of this, no current flows. When no current flows, what would happen? The voltage drop across this RL, which is measured as V out. V out is equal to 0. Understand that? V out is equal to 0 because no current is flowing. So now if we represent this in the form of graph, so how it would be represented actually? If it is represented in the form of graph, so during this period T0 to T1 already current flows. That's why we got the output voltage like this. Okay, this is your V out amplitude. This is your time axis. So during this T0 to T1 we got the output. But what happens now during this T1 to T2, during this time period, no current is flowing. So simply it is 0. Like this it comes. Understand? Again if you take T2 to T3, again if you take T2 to T3, again the positive half cycle will be coming in the input side. That's why the diode will be coming. Once again you will be getting the positive half cycle appears at the output side. Right. Again if you measure T2, T3 to T4, T3 to T4 once again, what would happen? It is equivalent to at the input side. At the input side, negative half cycle comes. That's why there will not be any current flow. So it is 0 like this. So again, once again, positive half cycle comes like that. It is getting repeated. Okay. So once again, I'll be showing you both the positive as well as, sorry, both the input as well as the output in a single graph. I'll be drawing for you. Okay. Wait a minute. This is the graph I am putting for you. So the top portion, this represents the input signal. Input signal means P input, P in. Okay. This is your time axis. This is also time axis. And here I am showing you in this the V out output signal I am showing you. Okay, fine. And this axis is amplitude. Here also it is representing the amplitude. Okay, fine. Right. So I am showing you now the input signal. So input signal is something like this. It is continuously coming. Okay. Sinusoidal AC current, AC signal is coming. So this is V input. We know that this is V input. So how the V out will be appearing because of this diode. Since diode is present at the output side, you will be getting the signal like this. Then no signal. Then signal. Then there is no signal. So signal will be present during negative half cycle, no signal will be present. Again, signal will be present during positive half cycle, then negative half cycle, no signal. Then signal present during positive half cycle, then no signal. Like that, it is continuously coming. Okay. So this is the output because of the presence of the diode, right? So this period you can represent like this is T0, this is T1, this is T2, this is T3, T4, and this period. Actually, the crossing period, right? T5, here T6, here it is T7, like that you can represent. Okay, right. Here also it is like this. This is T0, T0 to T1, the output is there. T1 to T2, no output. T2 to T3, output is there. T3 to T4, no output. T4 to T5, output is there like that. We are continuously getting. Okay. So, what is happening? This is input signal. I have told you this input signal is varying input. Okay. So, it consists of both positive half cycle as well as negative half cycle. So, it is a bipolar signal, AC signal, but when you check the output voltage, it is consisting only of the positive signal. There is no negative. So since there is no negative, it becomes unipolar. So when you have the unipolar signal, then it can be called as a DC, but it is not a perfect or pure DC. It is a pulsating DC. Since it is a pulsating DC you got at the output, this diode acts as the rectifier diode. Okay. So I hope you would have understood. With this, I'll finish the video. Then I'll pass on to the next topic in the next video. Okay. Thank you.